Hi and welcome to our next level 2 calculus video. In this video, it's going to be very similar to the last video. It's just a slight twist. We're going to find the point given the gradient. Let's go back and look at what we did in the last video just to get you brushed up again. Example 1, find the gradient of the curve y equal to x squared minus 5x plus 7 at the point 4, 3. So let's differentiate and let's use some formal notation just to get you familiar. Instead of using y dash, let's use dy over dx. So the x squared differentiates to 2x, the minus 5x differentiates to minus 5, and the plus 7 differentiates to 0. So the gradient rule is just 2x minus 5. Now we've been told the point 4, 3. So we know the first number is the x and the second number is the y. So we're going to use the x value of 4 and we're going to substitute that into the gradient rule. So we're going to go 2 times 4, which is 8 minus 5, gives us a gradient of 3. So at the point 4, 3, the gradient of the curve is equal to 3. Now you notice we only used the x coordinate. We had an x, y, 4, 3, but we only needed the x coordinate, the 4, to work out the gradient. We don't need to use the y value to work out the gradient. All right, so at the point 4, 3, the gradient of the curve is 3, which is 3 over 1, which is rise over run, which means here's the picture of the graph. Here's the point 4, 3. Here's a tangent. A tangent is a straight line that passes through the curve at one point, and the tangent and the curve have the same steepness, the same gradient at that point 4, 3. And we've worked out that the gradient of that at 4, 3 is equal to 3. Right, well, let's move into what we're doing in this video, which is basically just reversing that. Find the coordinate of the point on the curve, y equal to x squared minus 3x plus 4, when the gradient's 2. So notice we've been given the gradient's 2, and we've got to go backwards to find where it is, where on the curve is the gradient equal to 2. Right, well, let's do the same thing. Let's differentiate with the formal notation, dy over dx. The x squared differentiates to 2x, minus 3x differentiates to minus 3, and the plus 4 differentiates to 0. So we get a gradient rule of 2x minus 3. I'm just going to flip that around and go 2x minus 3 is equal to dy dx. Now we've been told the gradient is 2. So we're going to write down 2x minus 3 is equal to 2. We've put the gradient rule equal to the gradient of 2. And we're just going to solve this equation. So we're going to plus 3 on both sides, and we're going to divide by 2 to get x is equal to 2.5. So now we know the x value. We're going to substitute the x value back into the y rule, not the gradient rule, the y rule. So when x is 2.5, we're going to get y equal to 2.5 squared minus 3 times 2.5 plus the 4, and that gives us a y value of 2.75. So we've found the point on the curve that has a gradient of 2 is at the point 2.5, 2.75. So here's the function, the graph, y equal to x squared minus 3x plus 4. And the point we found is this point at 2.5, 2.75. And we know at that point, the graph, the curve, and the tangent have a gradient of 2. Great, thanks for watching.